Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, welcome to the Work System Engineering and Ergonomics tutorial. Before we start, let's pray together. Pray start. Finish. In this tutorial, we will discuss about manual material handling. Manual material handling can be applied in several activities, one of which is lifting as in the GIF. Based on this illustration, it can be seen that the operator has to move a lot of bricks manually, which by removing that many bricks repeatedly will certainly cause a thing called low back pain. Based on the case above, manual material handling has a role to find out whether the condition for the operator's appointment is safe and whether the load is in accordance with these conditions. So later we can make recommendation according to the RWL and LE calculations. Here's the outline of the material in this tutorial. The first is the purpose of the tutorial input and output, tutorial material, and end with a case study. Tutorial purpose. First, students are able to understand the concept of manual material handling. Second, students are able to know the load limit that can be lifted by workers, or RWL. Third, students are able to know the classification of activities, lifting index of manual. And next is input and output. For input, there is operator data and appointment design. The students, as usual, must know the demographic or characteristic of the respondent. For example, name, gender, age, occupation, and job description. And students must know the design of the appointment in the form of conditions, layout initial, and suggestion. And next, videos of the lifting process. During the appointment, the students must record from the side and from above, especially for asymmetric movements. Videos are recording with a maximum duration of 2 minutes for each of the prefix and proposed conditions. And the last is photo of screen capture. Video footage on screen capture from the side and from above to be analyzed and included in the report later. And for output, there is RWL analysis. The students will carry out processing on the basis of a screen capture appointment using a formula which will be explained later in the next slide. And next, there is lifting index of the prefix and proposed work. The students will get two values, LE, to do a comparative analysis whether there has been an improvement or not. And the last, recommendation for work design improvement. The students are able to provide an analysis related to the layout proposed given. Okay. Next, I will explain about definition of manual material handling. Manual material handling is a high-risk activity for the operator. As an industrial engineers are required to learn manual material handling to be able to find out the optimal value of the appointment for a job and also redesign the operator's work. Manual material handling consists of lifting, carrying, lowering, pushing. And next, guideline of NIOSH. NIOSH, or National Institute of Safety and Health, makes several provisions for a good and desired lifting process, and namely as follows. First, the load given is a static load. There is no addition or reduction of the load in the middle of work. First, the load given is a static load. There is no addition or reduction of the load in the middle of work. So, during the process of lifting box, for example, no one suddenly puts the box again under the load carried by the operator. And second, lifting is done by both hands. And the third, lifting or lowering is done for a max of 8 hours. 8 hours is the accumulated duration for lifting and lowering only, not working hours. And fourth, lifting or lowering objects should not be done while sitting or kneeling. So what is allowed is to be bent, upright, and also looking up, and the legs remains parallel so that the feet do not tiptoe. On this tutorial, use stoop lifting. So what is allowed is to be bent, upright, and also looking up, and the legs remains parallel so that the feet do not tiptoe. On this tutorial, use stoop lifting. And last, the lift should not be too fast, and the position of the foot is not supported on a narrow and slippery surface. It can be said that it is fast if the lifting process reaches 30 inches per second. And next, I will explain about RWL or recommended weight limit. Recommended weight limit or RWL is a recommendation for the limit of loads that can be lifted by humans without causing injury even though the work is carried out repetitively and for a long period of time. And heavy condition lifting that can be handled by healthy worker for a maximum of 8 hours of work and does not pose a risk of low back pain to the operator. And next slide is load lifting position. For one RWL will be seen from the position of lifting origin and destination, as well as if the values of H, V, and A is different, meaning there are two RWLs and video shooting is done from the side and above. The asymmetrical angle that is formed is seen from the position of the shoulder. So when there is rotation, next is RWL calculation. To find out the load limit that can be lifted in condition using the RWL, so there are 7 RWL variables that must be considered. The first variable is LC, or loading constant. The maximum load that can be lifted safely by humans based on NIOSH is 23 kilograms. This is based on the demographics of Americans or Europeans. While for Indonesian, especially female students, based on research from Wulandari, found of a value of 21 kg. And now in this tutorial, we will still use the load of LC according to the American standard, which is 23 kg for the linearity with the module. And next is horizontal multiplier or HM. Horizontal multiplier calculated from the center point of the body or ankle to the midpoint of the lifting hand. The minimum edge used is 25 cm, as most objects that are closer than this cannot be removed without disturbing the stomach. And next is VM or vertical multiplier. Vertical multiplier obtained from the midpoint of lifting or hand to the floor. The V values can be 0 cm if the object is lifted from the floor, and V values can be 175, which is the maximum recommended V to keep it safe. The range is used because most people have such a vertical range. And next is distance multiplier or DM. The value of D must be in the range 25 cm until 175 cm. If the measurement from the student is less than 25 cm, the D value input in the formula remains 25 cm. And next is AM or asymmetric multiplier. AM is the angle formed by the center of the body from the initial position to the position destination, and the shoulder is the support. And next is frequency multiplier or FM. FM is average frequency of appointments, measured in units of limit per minute. If the result is between two frequencies, it is rounded up to the larger one. And if the frequency is less than 0.2 lift per minute, the formula for the frequency multiplier is still written as 0.2 lift per minute. And next is coupling multiplier or CM. The coupling multiplier is based on the determination table coupling good or fair or poor by adding notes point that come from the highest degree. For good category, it is a good clutch having a good grip between the hand and the object is defined as a good container coupling classification or has an optimal design. And for objects that are not regulated, which are not always packed, such as casting, stock, supply, materials, and etc. This good category coupling fulfills the record, where the grip is comfortable and easy to grip. And for fair category, an adequate clutch is defined as a design grip that lacks an optimal design, and workers should be able to bend their fingers about 90 degrees under the container and is necessary when lifting a box off the floor. And the second, for an object that has an optimal design but does not have a handle or an object whose handle is detached, and objects can be carried by hand at an angle of 90 degrees. And poor category, it is an object that has a less than optimal design or a loose section or a large object that is uneven, difficult to hold, or has a sharp edge. A container is considered less than optimal if it has a front length of more than 40 cm, a height of more than 30 cm, and a raw and a slip surface, sharp edge, asymmetrical center of mass, and unstable constant, and or required the use of gloves. And it 3 example objects in 3 category of coupling multiplier. And next is lifting index or LE. After knowing RL, we will find out whether the value of the load lift by the operator is in accordance with the safe value by taking into account the factors in the RL calculation. In the calculation lifting index, the smallest RL value is used because the smaller one is more dangerous. The closer to 1 for the value of 6 variables formulated except for LC is the better for the RL. After you calculate and then get the result, you can categorize the LE values into the classification like shown in the PowerPoint. Okay, that's all from manual material handling tutorial. Thank you for watching and wassalamualaikum warahmatullahi wabarakatuh.